Now welcome to the next session. In the last session, we were in the middle of the question. That is, we were considering number of subsets of this particular set. S equal to set of 1, 2, 3, 10. We have a standard result NC0 plus NC1 plus NC2 plus and so on plus NCn equal to 2 power n. So earlier we had finished question number 1 and even question number 2, 4, 5, but we left question number 3, right? Now let us handle question number 3. What is this question number 3? The number of subsets of S having at most 2 elements. Having at most 2 elements. At most 2 elements means maximum you will have 2 elements. What is the least possible subset of S empty set? So empty set is denoted by this. This is basically a null set. That means a set having 0 number of elements. That means we are selecting 0 out of 10 elements. So this is one set. So therefore 10C0. So it may have one element. So plus 10C1 plus 10C2. So when you simplify this, you will get some number. So this number is, for example, 10C0 is 1 and 10C1 is 10 and 10C2 is 45. So therefore there are exactly 56 subsets of S having at most 2 elements, maximum 2. That means it can have 0 number of elements or 1 elements or 2 elements. So therefore the number of subsets of the number of subsets of S having 0 elements is 10C0. Because S is having 10 elements. The number of subsets of S having 1 element is 10C1. The number of subsets of S having 2 elements is 10C2. So therefore add all the subsets, you will get 56. Therefore the answer for question number 3 is 56. There are exactly 56 subsets of S having maximum 2 elements. Now question number 6. The total number of subsets of S. So that is given by 10C0 plus 10C1 plus 10C2 plus and so on plus 10C10. Therefore this is nothing but 2 power 10. This gives 1024. Therefore there are exactly 1024 subsets of S. So 0 number of elements, 1 element, 2 elements, maximum 10 elements. Note all these points. Now, when you recall the combinations concept, purely it represents number of selections. Now we discuss the number of arrangements that refers to permutations. Once I finish permutations, let us go to new concept, random variables. So the next concept is permutations. Suppose n is a natural number and R is a number ranging from 0 to n. R is a number ranging from 0 to n. Then the number of ways of arranging all things out of n things. Basically, permutations represents arrangements. So when you go through arrangements, the sequence is very, very important. So the number of ways of arranging or things out of n things is given by NPR. The number of ways of arranging or things out of n things is given by NPR. This P represents permutations and this is given by n factorial by n minus r factorial. N factorial by n minus r factorial. When you go through combinations, the expression for combinations is n factorial by n minus r factorial into r factorial. What is the difference between these two? Here we don't have r factorial in the denominator. There we have r factorial. If the denominator increases, then total ratio becomes decreasing quantity. So if the denominator increases, the ratio will be decreasing. So therefore, when you go to combinations, when you go to combinations, book 1 and book 2 is same as book 2 and book 1. But in case of permutations, the sequence of arranging things is important for me. That means, let me tell you one example. Suppose I have three symbols. So let us see in how many ways these three symbols can be arranged. They can be arranged like this. 1, 2, 3. This is one sequence. 1, 3, 2. 2, 1, 3. 2, 3, 1. 3, 1, 2. And this is 3, 2, 1. So we got totally 6 number of arrangements. So first 1, 2, 3. 1, 3, 2. So arrangements or sequence is important. So therefore I can arrange three symbols among themselves in 6 ways. Basically this 6 is nothing but 3 factorial. So how many symbols are there? 3 symbols only. In how many ways they can be arranged 3 factorial? Basically that is given by 3p3. So 3 symbols can be arranged totally in 3 factorial ways. 3p3 is nothing but 3 factorial by 3 minus 3 factorial. 3 factorial is 6, denominator is 0 factorial and 0 factorial is 1. So this is the way. That means permutations always refer to number of arrangements. So sequence is important. When you change the order, you will get more chances. That's why here in the denominator we don't have r factorial. But when you look at NCR, the denominator is increasing. Therefore, totally the ratio is becoming decreasing. So number of combinations will be always less when compared to number of permutations. Okay. Now this is one example. I will go for another example. Suppose in a college, we have 4 chairs in the first row. 4 chairs in first row. Suppose 3 students are willing to sit in the first row. This is first row. In the first row, there are exactly 3 chairs. 3 students having roll numbers 1, roll number 2, roll number 3 are willing to sit in 3 benches, in 3 chairs. So in how many ways they can be sit among these 4 chairs? Let us see. If they don't want to sit this position, so they can occupy this. So the number of permutations will be like this. Seating arrangements 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2. This is 3, 2, 1. So totally the total number of chances is 6. If they don't want to sit in the second chair, that means students don't want to sit in the second chair, so they will skip this. So they will occupy this. Again you will get 1, 2, 3, 1, 3, 2. This is 2, 1, 3, 2, 3, 1, 3, 1, 2, and this is 3, 2, 1. Again you will get 6 sequences. Next time they don't want to sit in this position, last but one position. They can occupy this. So again 1, 2, 3. This is 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and this is 3, 2, 1. Again we got 6 chances. 6. Suppose if they don't want to sit in the last chair, so but they want to sit in these positions. So again 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, and 3, 1, 2, and this is 3, 2, 1. Again 6 chances. So the total number of chances are 6 plus 6 plus 6. Total it is 24. So total chances is 24, and basically this 24 is nothing but 4p3. So what is 4p3? 4 factorial by 4 minus 3 factorial. So we get 24. So this is the way. Therefore, the number of ways of arranging all things out of n things is given by NPR, that is n factorial by n minus r factorial. Number of permutations will be always more when compared to number of combinations. Okay. So let us write these points. Let n be a natural number. Let n be a natural number and r be a number ranging from 0 to n. Let n be any natural number. Let n be any natural number and r be a number ranging from 0 to n. R be a number ranging from 0 to n. Then the number of ways of arranging all things. Then the number of ways of arranging all things out of n things. Then the number of ways of arranging r things out of n things. The number of ways of arranging r things out of n things is given by NPR, that is equal to n factorial by n minus r factorial. NPR equal to n factorial by n minus r factorial. One example. In how many ways three students can sit among themselves? In how many ways three students can sit among themselves among 4 chairs? In how many ways three students can sit among themselves out of 4 chairs? Out of 4 chairs. So first you can have this manual representation. They don't want to sit in the first position. They don't want to sit in the second, third position and fourth position. So for each sequence you will getting 6 chances. So 6 plus 6 plus 6 plus 6, 24. This is manual representations and this is fact permutations representations. Write all these points. Suppose we have a word, for example GATE. We have a word. In how many ways the letters of this word can be arranged among themselves? Just possible arrangement. Sequences will be different. So this is a meaningful sentence. Get. I can change alphabets. A may come this position, G may come to this position. A, G, T, E. It may not form a word, but arrangement is important for me. So the total number of symbols in this case is 4 factorial divided by, here the symbol G is repeated only one time, A is repeated one time, T is repeated one time and E is repeated one time. So therefore the total number of arrangements of letters of the word gate is 24. Suppose when you look at some words which have some repeated symbols. Say for example, I can have for example algebra. For example, if I have like this, now you can say how many symbols are there? 1, 2, 3, 4, 5, 6, 7. So therefore 7 factorial divided by, but here A is repeated twice. So divide with 2 factorial. Here L is repeated only one time, 1 factorial, but G is repeated one time and E is repeated one time. L, G, E, B, R. So 1 factorial. L, G, E, B, R. So 7 factorial is basically this is 7 into 6 into 5 factorial divided by 2. So this is 7 into 6 is 42. 21 into 120. So basically 21 120s. This is 122. So 240, 120 into 20. So this is 2400. So this is 120. So 2520. So therefore in this case This is 2520 ways. So in these 2520 ways, the letters of the word can be arranged. The letters of the word can be arranged. Why we were dividing with the factorials? Because sometimes I will write like this: A. This is one word: AALGBRE. But this year both are same. Even if you write different way also, it has to be counted only one time. But in this case, I wrote 7 factorial by treating each symbol as a distinct symbol. So 1, 2, 3, 4, 5, 6, 7. So these is A's I have counted only 2 times. So therefore 7 factorial. But unfortunately we have counted A 2 times. It has to be counted only one time. So divide with 2 factorial. Therefore in this way. But this symbol, this A both are same. L, G, B, or E. So this and this both are same. No difference between AA. Whether you write this A first or this A second, or this first or this A second, there is no differentiation. This and this are same. But unnecessarily we were treating each symbol as a distinct, even though if it is repeated many number of times. So 7 factorial by like this. So you will get 2520 ways. But in this case you will get 24. So write these examples. Concept: random variables. Very, very important concept. Now let us see. Generally we frequently come across with 2 types of words in mathematics. One is constant, another is a variable. Suppose I am conducting an experiment. What is my experiment? So just noting down the temperature of a particular city from morning 6 to afternoon 2 o'clock, for example. So for every 1 hour, suppose sometimes there may be some changes in the temperature. Sometimes there can be constant temperature. So if a temperature does not change from time to time, it is called constant. If it changes frequently, it is called variable. A variable means a quantity which is frequently changing, that is called variable. If a quantity does not change, it is always fixed. In that case, it is called constant expression. Now let us see what is a random variable. When you conduct an experiment, suppose I have conducted an experiment. So assume that the number of outcomes are O1, O2, On. So we have n outcomes: O1, O2, O3, and so on, comma, On. We have n outcomes. Now, if I conduct an experiment, frequently outcomes are getting changed. Just take a coin. When you toss a coin, continuously you may get heads. Sometimes continuously you may head. Sometimes alternatively heads and tails. So that depends on the rotation of the coin. In what position you are spinning that coin. That varies from position to position. Therefore, frequently the outcome of an experiment is changing. So if all outcomes of an experiment are assigned to a single variable, that will be called as a random variable. So random variable. Random means frequently changes. Variable, it frequently changes. So a variable which is assigned all outcomes of an experiment is called a random variable. See, suppose I have a random variable x. Generally random variables are denoted by the alphabet x. So x can be like this, ht. X can be like this, ht. Now what are the corresponding probabilities p of x? Probability of getting head is 1 by 2, probability of getting tail is 1 by 2. Therefore in this case the probabilities of outcomes of all experiments are specified very clearly, and this is called probability distribution function. This is called probability distribution function. Shortly we call it as a PDF, probability distribution function. I will tell you later why it is called distribution function. Now we can see here all outcomes of an experiment are assigned to a single variable. Therefore this is called a random variable, and probabilities of all of its sample points are clearly mentioned. Therefore this is called a PDF. Suppose when you look at die, the random variable x will be like this. So it may take 1, 2, 5, 6. The corresponding probabilities will be like this. Probability of getting 1 is 1 by 6. Getting 2, 1 by 6. So 1 by 6 for all sample points. Now in this case, the random variable x is taking all sample points. In this case, the random variable x is taking all sample points. So when you roll a die, the outcomes can be 1, 2, 3, 4, 5, 6. So sometimes x can be 3, x can be 4, x can be 5. That means x is not taking a fixed value. So therefore x is a variable, but this variable is assigning, this variable is taking the values. What are those values? Those values are nothing but sample points of an experiment. So if all outcomes of an experiment are assigned to a single variable, then this is called a random variable. If the probabilities of all sample points of an experiment are assigned very clearly or specifically, then this is called a probability distribution function. In this case, all probabilities are uniform. 1 by 6 to all sample points. There 1 by 2 for both sample points. It may not be the case in all cases. Let us say, suppose I have an experiment having 3 sample points, 1, 2, 3. Suppose my probabilities can be like this. This is 0.7 and this is 0.2, this is 0.1. So my PDF can be like this. Now you can see the random variable x is taking 3 different sample points, 1, 2, 3. The probabilities are like this. This is 70%, 20%, 10%. So totally it gives 100%. So here probabilities are not same, but the random variable x may take either 1 or 2 or 3. So this is a variable which frequently changes its values. Sometimes output can be 1, x can be 2, x can be 3. But here probabilities are specified very clearly. So it is a PDF. So basically random variable means if all outcomes of an experiment, are assigned to a single variable, then it is called a random variable. Normally it is denoted by the alphabet x, right? And one more definition we had discussion is probability distribution function. I will tell you why it is called distribution function. Add both the probabilities, 1 by 2 plus 1 by 2, you will get 1. Add all the probabilities, 0.7 plus 0.2 plus 0.1, you will get 1. Add all these probabilities, you will get 1. So here 1 is distributing. Sometimes it can be uniform, sometimes it can be different. So here 70%, 20%, 10%, it is not uniform, but still it is called probability distribution function, right? How we were distributing 100%. So 20% to one outcome, 70% to one outcome, 10% can be one outcome, or equally it can be distributed to all sample points. That varies from situation to situation. All right. So first write the definition of random variable. If all outcomes of an experiment, are assigned to a single variable, if all outcomes of an experiment are assigned to a single variable or assigned to a single variable, then it is called a random variable. If all outcomes of an experiment are assigned to a single variable, then it is called a random variable. So stop. It is denoted by x. Let's put the heading probability distribution function. Shortly we write it as PDF. Frequently they use the word PDF even in the examination. PDF, probability distribution function. If the probabilities of sample points of an experiment, if the probabilities of sample points of an experiment are specified, then it is called a PDF. If the probabilities of sample points of an experiment are specified, then it is called a PDF. So you can have the examples. This is example 1. This is example 2. Example 1 is coin. Example 2 is die. This is some general experiment. Example 3. Write example 1, 2, 3. Types of random variables. We have two types of random variables that depends on how many sample points a random variable takes. I have a random variable x. If a random variable x takes finitely many sample points, limited number of sample points, as we have seen examples just before now. In the first example, we have two sample points. X may take either head or tail, only two sample points. That is, X is taking finitely many sample points. In the second example, X is taking 6 sample points, 1, 2, 3, 4, 5, 6. That is related to die. In case of third example, X is taking 3 sample points. But in all the cases, X is taking finitely many sample points. In that case, that random variable is called a discrete random variable. So we have two types of random variables. One is discrete random variable. Shortly we write it as DRV. And second random variable is continuous random variable. Second one is a continuous random variable that we frequently write it as CRV, continuous random variable. So why it is called continuous random variable means the random variable x takes infinitely many values. In general, it runs from minus infinity to plus infinity. Minus infinity to plus infinity. So that means continuous random variable generally takes values from minus infinity to plus infinity. Continuously you will get values for random variable. But in case of discrete, there is some separation. Suppose you can see, suppose x values are like this, 2, 3, 9. Now x is taking integer sample points. X is taking integer sample points. Suppose y is a random variable which takes sample point like this. 2.3, for example 3.7, for example 5.7. These are the sample points of a random variable x. Now these are the sample points of a random variable y. But here y is taking real sample points. Y is taking real sample points. So therefore such random variables are called continuous random variables. One simple point, when you are dealing with a discrete random variable, it has finitely many sample points or it will have only integer sample points. When you look at continuous random variable, it takes infinitely many sample points. Generally it runs from minus infinity to plus infinity. So minus infinity to plus infinity means it is running on entirely x-axis. So the limits of continuous random variable is minus infinity to plus infinity, but in this case it takes only finitely many sample points. So based on the number of points a random variable takes, we have classified a random variable into two categories. One is a discrete, another is discrete means there is some separation. So between 2 to 3 there is some separation, 3 to 9 separation is there, but when 2.3 to 3.7 there is no separation, we have infinitely many sample points. So if a random variable x takes finitely many sample points, then this is called a discrete random variable. If a random variable takes infinitely many sample points, then this is called a continuous random variable. Okay. So first you write this discrete random variable, DRV, discrete random variable, DRV. A random variable which takes finitely many sample points. A random variable which takes finitely many sample points. A random variable which takes finitely many sample points or integer sample points. A random variable which takes finitely many sample points or integer sample points is called a DRV. Is called a DRV. Second one, continuous random variable. Continuous random variable, CRV. A random variable which takes infinitely many sample points. A random variable which takes infinitely many sample points or real sample points. A random variable which takes infinitely many sample points or real sample points is called a CRV. is called a CRV. Now we discuss three statistical parameters: mean, variance and standard deviation for discrete random variables, followed by for continuous random variables, right? Suppose here the concept is mean, or this can also be called as expectation. Mean or expectation. Suppose x is a discrete random variable with a PDF like this, probability distribution function. So random variable x values are x1, x2, x3 and so on xn. The corresponding probabilities are given like this: p of x values, they are p of x1, p of x2, p of x3 and so on p of xn. P of xn. So here x is a discrete random variable whose PDF is given like this. Now the mean or expectation of x is denoted by E of x. This is called expectation or expected value of x. This is also read as mean of x, mu x, mean of x, and this is given by the product x1 into p of x1 plus second product x2 p of x2 plus and so on plus x3 times p of x3. So this is my DRV, discrete random variable. So whose PDF is given like this. Since it is a discrete random variable, it takes finitely many sample points. But sometimes even if it takes infinitely many sample points, if all the sample points are integer points, you can apply DRV properties, no issues. Okay. So here x is a DRV with a PDF like this. X is taking n sample points, x1, x2, x3 and so on xn. These are the respective probabilities. Then the expectation or mean of x is denoted by E of x. Expected value of x or mean of x is given by E of x equal to mu x equal to x1 into p of x1 plus x2 dot p of x2 plus and so on plus x3 into p of x3. So sample point into probability plus this into this plus this into this plus and so on plus this into this. Okay. So this is the mean of a discrete random variable x. Let me tell you one example. Suppose I have a sample points like this. X values 1, 2. The probabilities are like this. Suppose this is 0.3 and this is 0.1. Now this is the PDF of a random variable x. Therefore the expectation of x is, this is an example. So 1 into 0.7 plus 2 into 0.3. So therefore this is 0.7 plus 0.6. So therefore this is 1.3. Okay. So first write this heading: mean or expectation. Mean or expectation. Let x be a DRV. Let capital X be a DRV with the following PDF. Let x be a DRV with the following PDF. Write this tabular form. Let capital X be a DRV with the following PDF. Draw this table. Let x be a DRV with the following PDF. X values x1, x2 and so on xn. P of x values P of x1, P of x2 and so on P of xn. Then the expectation or mean of x. Then the expectation or mean of x is denoted and defined as, then the expectation or mean of x is denoted and defined as E of x equal to mu x equal to E of x equal to mu x equal to x1 dot p of x1 plus x2 dot p of x2 plus and so on plus xn into p of xn. Write this example.